In this video, we shall learn about how to use R to fit a generalized linear model. First, we shall follow the footsteps of D.J. Finney and carry out a similar analysis without using any specialized generalized linear model tool from R. So let us create our data set. I have the doses. Suppose I use the doses 7 to 13, and n is the number of doses that I am using. So I have 7 to 13, and then I have n, the number of doses that I am using, which is 7. Now I will create a list of proportions of death, prop death. So I start that with an empty array and I create a matrix. That's my data matrix. My data matrix is going to have all the doses in the first column, and for each mouse, whether the mouse is living or dead, in the second column. So I will have as many rows in it as there are mice. Now I run a loop for I from 1 to n. So I'm doing it for each dose. For each dose, I will take 100 mice. So for those 100 mice, I will have different actual lethal doses for those mice, the maximum that they can endure without dying. So I create them randomly. This is a simulation study. So I'm creating the mice randomly, or their lethal doses randomly, or norm 100, and I make the mean say equal to 0. So these are the actual lethal doses, my x1 to x thing in, where these are latent variables. In practice, I will not be able to see them. Okay, so I create them, and after that I have to see whether the mouse is living or dead for these 100 mice. So what I do is I take the ith dose level that I'm working with and see if it is greater than or equal to the lethal dose. If it is, in that case, the mouse will die. So dose is greater than or equal to lethal dose. That gives me a Boolean thing. So I am doing it for all the 100 mice in one line. So I create this dead, and then I create that part of my data matrix. So I am appending, so I am using this R-bind. I have my data matrix and it is growing. For each step, I am adding 100 additional rows to it, corresponding to the 100 new mice that I am deploying for this new dosage. Then inside that extra thing, I have a C-bind, where in the first column, I am just repeating the same dose I. In the second column, I am writing dead, true, false things. So that's the data that I create. And then finally, I compute the proportion of deaths that I get for that particular dose. Since dead is a Boolean array, so true, false, zeros and ones, if I just take mean, that will basically give me the proportion of ones. So I compute the proportion of death for the ith dose, and I come out of the loop. So I can just show you what I get. I have team mat. It is 700 by 2. 700 because I have got 7 doses. For each dose, I have got 100 mice. And the two columns are, the first column gives me dose, and the second column gives me dead or not. So I can just show you this mat. It's a huge thing. So you can see initially I'll have 0, 0, 0. It's a very low dose because on an average it is near 10, and I'm giving it dosage of only 7. So all the mice are living initially. At 8 I had 1 death. I saw 1 death. Then I go on. At 9 the number of deaths is increasing. At 10 I have quite a few deaths. 11 more dead than alive. 12, 13, everyone is dead. And I can see that if I look at the proportion, so I can even plot the proportion of deaths against the dose. So I already have that command here, so I will do it from here. So I am plotting it, and you see the plot. This plot is definitely like the sigmoid curve, namely we are seeing that Gaussian CTF showing up. So that was the plan of DJ Finney. We have estimated the probabilities. If I plot, I should see this Gaussian CTF. So if it doesn't look like the Gaussian CTF, then that normality assumption is not good. But then we have to fit that Gaussian CTF to this, which was not very easy at that time. So what DJ Finney did was, he took phi inverse of that. Phi inverse is implemented in R as the Q norm function, quantile of normal. So now we plot those with Q norm. So I just do this, and you can see that now the graph is a pretty straight line. So you can just fit a line to it, and that's how basically DJ Finney did his first Probit regression. Now this is a very crude method, and also if we try to apply our LM function to this to fit that line, we will see that something will go wrong. Let's just try it out. So we just try it out, and you will see, ooh, I have got an error message. The reason is, you see, when I apply the least possible dose, namely the least possible dose was 7, then not a single mouse was dead. So the proportion was 0, and you took phi inverse of that, that gives you minus infinity. And that minus infinity causes problem. Of course, you can avoid that. You can just set it something instead of minus infinity. You make it minus 3 or something. So this process is not entirely free of trouble. And also it's a very crude technique. Now the way we use it in the modern day is to use maximum likelihood estimate. And that's what I'm going to talk about now.